Hello, this is my Lab 5, and I'm doing it on planetary motion again, but this time with a sort of twist. So this is the introduction. So the purpose of this lab is to model and understand celestial motion if the larger body isn't fixed in space. So for the lab 3 we did, but there was we were looking at celestial bodies. We looked at it as if the larger object, usually the sun or the black hole, was fixed in space. But I just want to see what would happen if both of them were moving at the same time. And so some of the models and principles include Newton's second law, gravitational potential energy, and conservation of energy. Um, and so there's a preview of the finding from the code. You can see two objects, and they're both orbiting each other. Yeah. So here's some equations that I used. There's Newton's second law for seeing for calculating forces, and then yeah, and then there's also the force of gravity, which is like the main force being used here by the planets, causing them to accelerate. And then there's the velocity update equation, which was used to see the velocity at different times in the code, and also the same can be said for the position update equations used to see the update in position. So for the models and assumptions, I used WebPython to perform calculations, and I assumed that these two bodies were the only things imposing any forces in the system. Nothing else was happening, and that also the bodies are perfectly round, so that they're the the mass is like equally spread out through the bodies, and to make sure that there's no like difficult calculations that we don't really know how to do. So the systems and surroundings. The system is we're looking at the smaller star. Um, and then the surroundings is the larger star, which is imposing the forces. As for the initial conditions, I started with the base code from Lab 3, and I changed it a bit to allow for both of the objects to move. Um, and and it had a random starting velocity based off of your the name you put into, and then also both stars start with a starting velocity based off my name, and then yeah, so there's the whole thing after that, which I'll get into, is about finding the masses of these two stars to allow for this starting velocity to work. Um, yeah, so as for the details of the experiment, the unknown initial velocity is what we started with, and I had to input two different masses for each of the stars to allow for a stable orbit of the two. Um, and I was able to find that two masses that worked pretty well were the 5.25 e to the 40 and 2.5 e to the 40. Um, yeah, this is I don't think this is the only one, but this is just the one of the ones that I found that worked really well. Um, and so as for the code, I changed it to allow both masses to move, of course, and I changed it to stop like in the second part of Lab 3, where if the rocket crashed into the moon, or rather, yeah, then it would just stop the whole thing. I did that so that I could just keep inputting masses until the whole system worked. Then as for similarities and differences, I'm just gonna compare it to a real binary star system in real life. Um, so the similarities is that in most cases, one star is much larger than the other in order to keep the balance, which is something that I had in mind as well, and that the velocities are they're probably much different. Um, than what they are in real life, which causes a difference in masses. The stars that masses I used for my stars were incredibly large, um, much larger than most stars. Yeah. So as for sources of errors, there were a bunch of approximations, like there's no outside forces and some other things to make it just easier to run the simulation. And then also I used trial and error to figure out the two masses, and there's definitely a more optimal solution to this, but that just wasn't in the scope of this lab. And then as for the additional questions, the third star was added to the mix. It's called a three-body problem. It's widely discussed and just people are trying to solve it, but some orientations have been solved, but most have not. So as for what could happen, it depends on its starting velocity, where it is, where the other two are. A lot depend on it. And as for if planets were added to the system, would it be able to orbit like a single star system? It is possible. and there are two types of orbits. It could either be one star or both stars, but again, it can be quite hard to accomplish. Thank you.